Welcome to Computer Architecture. This mini lecture, we are going to talk about strings and pointers, especially in C. The first thing to understand is how do we represent strings? We usually use ASCII code, the full name is American Standard Code for Information Interchange, and most computers today use this 8-bit, which is a byte, to represent characters. For example, space is 32, the 0 is actually 48, A is 97, so on and so forth. And one observation is that when we represent English letters, the upper and lower cases, they actually differ by exactly 32. So if you think about it, actually, we can use this observation as a shortcut to check or to change from one character to the other character to change the case. Why is that? Then the second thing to think about is that once we define the ASCII code, we can actually represent numbers as a strings using these ASCII digits instead of just use integers. But what would be the disadvantage of using this representation? Now we have the notion of byte, but then how do we move those things inside MIPS? The instruction is called load byte. It's a LB, which is a register, and then specify the memory address that we want to do. Okay, so the pseudocode is that first we are going to read those things from SP because this constant is 0. Then once we read that, we will put that into the rightmost 8-bit of the register. Okay, so because the byte is 8-bit, we only care about those things. And similarly, we also have the instruction called store byte. Then now we know how to represent character, but now how do we do strings? And there are usually 3 approaches that we can do. And I suppose our string is called S. So the first position of the string S tells us the length of the string S. Or we can have something like data structure. We have a complete variable that tells us the string S length. Or we can do that the last position of the S actually is indicated by a special character, and that's a C approach. We also call that as a null-terminated string. The reason for that is the terminating character is 0. So the example is that if you want to represent a string as a 3-character, 3 letters, UML, then we can store that as 85, which tells us it's an uppercase U, 77, the uppercase M, and 76, the uppercase L. Then when we encounter, oh, here's a 0, then we know that it's the end of the string. So to exercise that you can do is that now inside string copy, then how do I translate that into MIPS assembly code? And similarly, for string length, how do I do that? Now the second notion is about pointer. Then now let's use in the C code for doing string length as an example. So this is the function for string length. We are given a string, okay? Then we want to return the length of the string, which is an integer. So first, we initialize it as a 0. Then we just check the string length, treat it as an array. And then we try to figure out whether that symbol is 0 or not. If not, we keep incrementing the length. Finally, we return that. Oh, similarly, we can interpret this thing not as an array, instead as a pointer. So we just check whether this thing, the thing that pointer points to is a 0 or not. If not, we keep incrementing it, and then we return the length. And why is this important? Because this tells us something about pointer. So what is a pointer? Pointer is just an address to the memory. And when we say dereferencing, means that we are loading the data from the pointer's address. And important thing is that the pointer actually has a type. And then the type tells us that the size of the data that tells us that how do we do the load? How do we load data? So if it's a load byte, then it's a character in the chart variable. If a load half byte, which is sorry, not half byte, but a half of the register, half word is a short. We want to load the full word, which is an int, or we want to load float. We can also do that. Then once we have like this idea of a pointer, which is just address, we can do arithmetics on that. Then when we say plus plus, make the pointer, move the pointer to the next element. But now you might ask, how do I know what the next element is? And the idea is that remember the pointer has a type. So the next element simply move the size of the type, size of your data structure. All right, so that's all for today for the mini lecture. We talk about two things. The first is about strings, and then once we have string, the concept is called pointer. So it's important to remember that pointer has a type, and then when we do the pointer arithmetics, we need to know the type.